The term net torque refers to the idea that because torque has a direction to it, you can't simply add values together. Sometimes you add, sometimes you subtract, depends on their relative directions. So we have two forces here, 25 newtons and 10 newtons, each creating a torque about 0.0. And so we're going to calculate each of those torques individually. So our first torque, let's say, is related to the 25 Newton force. Okay, so first we'll find the magnitude of the torque. Officially, that should be written like this. That's the official terminology or notation for magnitude. So the 25 Newton force originates 2 meters from the pivot point or the axis. It has a strength or a magnitude of 25 newtons, and then we need to know the angle between those two vectors. So let's take a closer look here. The direction of the moment arm is this. The direction of the line of force is like this. So those are our two directions. We just need an angle between them. The 30 degrees that we were given is not the correct angle. We could either use this angle here, 60 degrees, or we could switch around and use this angle here, that would be 120. Either one will give us the correct answer. Let's just go ahead and use 60 degrees. And so we take 2 times 25 times the sine of 60 degrees, and that comes out to be 43.3. Okay, and again, that is Newton meters is our unit for torque. Now that has a direction to it, and so the direction of R points like this. That's how our hand would initially be pointed, and then our fingers would bend in the direction of the 25, and that would force our thumb to point out of the page. So that's the direction of this torque. Some people consider that to be the positive direction out of the page. All right, so then we have this other force, the 10 Newton force. Let me get rid of my scribbles here. So my other force of 10 newtons is going to, I'm going to use my R value here from O to here. That 4 meters is R, or the magnitude of R. The magnitude of the force is 10 newtons. And we got to look at the angle. Okay, in this case, the angle given is actually the correct angle. So here's the direction of R. Here is our line of force, and so the 20 degrees is the correct value to use. So the sine of 20. And so that comes out to be 13.7 Newton meters. Now this torque actually points into the page. It's a little trickier to do, but again, point your fingers in the direction of R, and then you kind of have to curl them backwards. Make sure you're using your right hand. And in order to do that, you actually got to flip your hand all the way around, which causes your thumb to point into the page. And again, just like this is sometimes considered positive, many people consider this to be negative into the page. But it's all kind of a matter of perspective. So the most important thing is that they are opposite of each other, and the 43.3 is the bigger torque. So my net torque, okay, that's how we would write that with the sum or the sigma symbol. I would say 43.3 minus 13.7, and that should come out to be 29.6 Newton meters. And then again, the larger one, we keep that direction out of the page.